as we have these short cycles for, products and sales and marketing is always driving, get new fresh products out there as fast as you can. But the reality is that, we haven't even paid for the tooling half the time.
Welcome back to part 2 of our special episode with Bruce Coventry and Marc Rosenmayr. If you missed part 1, be sure to check it out. We covered the barriers that slow down AI adoption in manufacturing and what it takes to overcome them with smart leadership and pilot-first approaches. Now in part 2, we go deeper into what's changing across the industry, from the rise of integrated system thinking to shorter product life cycles, and the idea that the factory itself is a core product. We explore what it really takes to build smarter, faster, more resilient manufacturing operations.
This is a topic I think I am involved in thinking about every single week, iterating. We have processes with our AI initiatives of, what is the global standard solution supposed to be, but then what is the every single site approach? And sometimes it's regional. How is this working in Mexico? Obviously in the US, how's it working in China? How's it working in Europe? And then, but even just plant by plant, 2 different plants in the US, 2 different plants in Mexico can be really different. I want to take this to you, Marc, because I think everybody knows how powerful AI is, or they're waking up to it at least. They're seeing it, they're using it more, and they're aware that there is shared data, shared expertise, shared context across their factories. And so what a shame it would be to not have some degree of standardization. Bruce talked about in automotive, having those processes rigid and controlled is just obviously a good idea. And, among many other things, for example, your AI can learn from itself. It can learn from experts here and there and there. So we know that there needs to be some degree of standardization, but as Bruce was talking about too, like there are just such differences plant by plant. So what's your take on the same topic? How is this done the best way?
Yeah, it sounds a little bit like a contradiction, right? The standardization versus the site level autonomy and empowerment. But I think another complexity here is that it's really a moving target. If you think about 20 years ago, most of the automotive companies were international. So that means, yes, they had a global footprint. They were present in almost all of the countries, where cars were manufactured, but they were very disconnected. So the regional authority was very high and the standardization degree really low. And then over that time frame, companies invested a lot of money in standardization, starting with IT system, following by processes, ways how they communicate, and so on. And then even to products, most of them today have what they call global product lines. That means they have a certain core technology which has been developed in one region and is now deployed and potentially adapted a little bit in other regions. Now, the challenge here, or the benefit maybe first, is really it allows them to avoid that they need to reinvent the wheel again and again, right? At the same time, the challenge here is really that you lose their capability to easily react on regional trends. And I would say what we have just recently seen, with the electrification and connectivity becoming such key drivers in the automotive industry, they all happen at different pace in the different regions. Asia is clearly leading, if it comes to interaction with the car, digital features in the car. Europe, I think, is following. Both of them are very active in the electrification space. And now the US is a little bit has a slower pace here. And with the new administration, particularly the electrification, we'll see that this is no longer a priority. So these companies need to react on that. And I think finding the right balance between having a global product platform and global processes will be challenged, in particular with the AI. You mentioned it, that AI creates so much data and allows you to do all these analysis and improvements. But if you are not empowering the team locally to do it in the best possible way as they need it, then it's not giving them the full benefit. And again, despite with all the standardization, we have differences in the plans. a lot of investment went into these manufacturing lines, and they've been built at different point in time. So the machines have different capabilities. I think Bruce already mentioned that. Some of them are very old. They are hardly connected. And other machines, like in particular in the SMT and the PCB manufacturing, are very modern, have all the sensors and communication capabilities, but they are typically still operated in a slightly different way. So if you add the layer of AI and data collection now on these different locations, you need to have a way to interpret and analyze and deploy measures in a different way as it makes sense. So I think we have reached or maybe crossed the peak of standardization, and we are now moving back to a more localized and customized and tailored approach. That's at least what I'm observing here.
Very interesting.
Yeah, that's interesting. Bruce, based on what Mark just said, I kind of want to come back to something you brought up a minute ago when you were talking about when you walk the floor, the Gemma walks and feeling things and really understanding it. Kind of takes me back to thinking, there's low hanging fruit in here. We're talking about the opportunities for these rollouts and the site autonomy, but there has to be, like I said, there has to be some commonalities that you see across plants and sites and manufacturers worldwide in areas that are low hanging fruit right now. So I want to come to that. How do you as an advisor in your advisory role, how are you guiding your clients and manufacturing firms to choose partners that really support technical excellence on the factory floor? It just, and listening to Mark, I'm thinking, we've got to get past dashboards at some point. There's, how do you advise people to find the right providers for it?
Well, it starts from really trying to understand what's going on in manufacturing. The thing that we try to do from a consulting perspective is make sure that we're spending time in our clients' facilities and understanding exactly how they operate. The other is doing the research, and doing deep dives, and now AI is much more available and and helpful, to be honest, because now you can scrape the internet and identify all kinds of things, and then best practices, and a lot of them are outside of normal, what we would consider heavy manufacturing or automotive manufacturing. You look at food and beverage or some of the other high velocity kind of manufacturing processes, and those are starting to look a lot more like battery plants and maybe magnet production for electric motors and things like that, where you've got extremely high volumes where you're making millions and millions and millions of parts. There's one engine in every gasoline or ICE vehicle. Maybe there's two electric motors, but you look at components like battery cells, and they're literally thousands and thousands, within a given vehicle. So it can be, or at least hundreds. So it can be a really, eye-opening experience to see how people in other industries, are doing it. People that operate at a different scale, different cycle times completely. And the automation's got to work 100% of the time, and you've got to have good ways. But the fundamental thing that we try to do is understand within the available, set of alternatives for our clients where the best technology is. That's why, as Mark said, we spend a lot of times trying to understand where the startup technologies are. A lot of times those are in incubators. A lot of there are pockets of excellence all over the world. Whether it's Tel Aviv or whether it's Silicon Valley or whether it's Shanghai. There are many, Stuttgart. But there are many different opportunities to see some of the best technology in the world. And then one of the things that we want to be able to do is to vet that technology so that we can identify what technologies will buy their way onto a vehicle or into a manufacturing process within the next 2 or 3 years. I mean, those are the ones that we want to go out and be able to help accelerate the commercialization so that they can move very quickly, but they understand the challenges of what it's going to take to become an automotive supplier, which is no small deal. So, that's one. Really understanding what the customer requires, and then trying to move beyond that, and then making sure that we're vetting and making sure that we're only bringing the kind of companies to our potential customers or to their potential customers that we know from our automotive perspective will really make it into the process or onto the vehicle.
You
Yeah.
talk about how becoming an automotive tier supplier is a big deal. Remaining a top automotive tier supplier is a big deal. Mark, it's been like ringing in my head still from earlier as you were talking about this mega shift from building all the parts as optimized as possible to now the systems thinking mindset of the OEMs, the software defined vehicle. How is that shifting what it means to be a great automotive supplier, and how your manufacturing evolves in this new era?
Yeah, so the automotive industry sees another disruption. It's with the software-defined vehicle, we are really moving away from just providing components as the supply base did in the past, right? So there was a specification, a list of requirements, and then suppliers developed typically the hardware and the software, and both was optimized, as I already mentioned, to, in particular, achieve the lowest possible cost. Now, that really locks you in a certain functionality, because these components, they have a certain microcontroller, they have a certain memory, they have a certain performance, they have a number of IOs. All of that really defines what that component can do. And if you want to later on make any changes, you really almost go back to square one. You need to pick a different microcontroller, you need to update all the software, you need to go through the full validation. So this is very different than what consumers expect today, right? Coming from the consumer electronics, the smartphones, where you have constant new updates, the same hardware, the same phone can do different things, with new apps or new features. And the automotive industry is under tremendous pressure to implement the same way here. So this is really shifting now the development from what is possible within a given framework to what are the consumer use cases really we want to implement. And then starting with the software, which can do that. And the last is really the hardware, which follows and needs to support that. And if we now talk about manufacturing, that really means the hardware is getting more standardized. It's broader in a way that you have additional performance capabilities, which might not be used today, with the features which are implemented, but it allows you really to update the software later on. So you need to optimize the platform, but you need to have that kind of additional, I call it future-proof capability of the hardware. Now, maybe more interesting is really how this is changing the development cycles with engineers, because in the past, as I mentioned, you have a requirement. The supplier took it took him maybe 6 months, sometimes a little bit longer, to provide first samples, and the samples are getting validated in early prototype cars, while the supplier keeps working on it and builds tools and then builds parts out of production tools and on a production line, which then again go through the full validation. And all of that takes typically, I would say, between 18 and 24 months. Now, we are moving to what is called an agile and the DevOps methodology. That means development and operations are going hand in hand. You have a certain level of your product maturity. You push it out, you test it, you keep going, you repeat that on a more regular basis, maybe every 6 months, instead of every 3 years. And that is only possible because you keep the hardware pretty stable. The hardware is the part which needs to be validated longer, which takes more time for the validation. So you really want to keep that as stable as possible. And now you work on the software side. And with features like over-the-air updates, you can do that even after you sold the car, right? So it's really no longer just build it and ship it and forget it. It is a continuous improvement. And many of these features, again, have been introduced by Tesla, and the rest of the industry realize how many advantages this has if it's implemented. The transition from the traditional way to the new way of it takes time, and it takes effort, and sometimes really requires that you completely change your internal organizations, how you operate a supplier company, for example, or a development team or manufacturing.
I just want to build on what you said so fast because, yeah, Mark, when you and I were first meeting each other, you were articulating this to me, and it was a aha moment for me. And maybe some of the listeners here, they're like, I already got it. But just to, one of my aha moments, like I got in my garage out here, I've got a Subaru Outback, which is one of these internal combustion engine cars with trims. And I bought the touring trim instead of the limited trim. And so it has hardware that wouldn't be there if I'd bought the lower trim, and there is no upgrade to that. And then I also have a Tesla Model 3, and it's just got the hardware. It's got cameras that it's not using yet, but maybe it's going to drive itself as a taxi in the future with an internal camera at some point. And that connects, as you were saying, to what Bruce said, that the cycles are actually longer with Tesla, which sounds counterintuitive at first. I thought innovative is always faster. Well, it's faster to over-the-air update, but it's longer on the hardware platform, which equals more time to optimize the factory with automation and improvements, and then not just assuming, I'll leave this process however it is, like keep improving it through a long platform cycle like the Model S platform. And so I think, at least, when you guys first explained that, I kind of knew that, but it clicked in my head. So I hope for the listeners too, it's like, that's kind of an aha moment of how these different trends are coming together, and really meaning that now as a suppliers, if you can make that shift with your OEMs to the software-defined vehicle, you may have these longer, more capable hardware pieces that need to be made that fit as part of the system, and it becomes more important to invest in the optimization and the automation around it at the same time.
Andrew, that's a critical point. I think that is lost on a lot of people. As we have these short cycles for, products, and sales and marketing is always driving, get new, fresh products out there as fast as you can. But the reality is that, we haven't even paid for the tooling half the time, when we're moving from one program to another program. So it's a real big problem for the automotive industry. That, and the fact that, many automotive companies are doing exactly the same thing, and they, need to decide what differentiates what they're doing from what their competitors doing, or maybe they ought to be doing it together, like Hyundai and GM just announced, where they're going to share vehicle platforms. So I think some of that is coming through, but your point is a really important one when you think from a manufacturing perspective. Those longer cycles allow you to really debug and prove a process out to where it is absolutely the most efficient it can possibly be. And then you build upon that for your next process. But I think those longer cycle times do have a lot of advantages.
Yeah, it kind of comes down to what we're calling product now. It looks different than it did 15, 20 years ago, right?
It is.
So,
Yeah, very much.
Bruce, I want to jump off of that for a minute then. You look at some of the advantages then that some of these large manufacturers, you've seen a massive amount of growth in Flex and Jabil over the last couple of decades, and you think about the advantages that they have right now in just the sophistication that they have in manufacturing, especially electronics, right? What are some of the if you look at the amount of innovation across automotive that you've seen in US, European, you mentioned some in Asia as well, and really seeing the rise of the global contract manufacturers like we said, Flex and Jabil in this space, what then are some of the lessons that automotive tier 1 and tier 2 suppliers can learn from these MES leaders who have already embraced that centralized kind of AI-driven manufacturing mindset?
Yeah, maybe a couple of thoughts on that one. Yeah, so I would say in the past, the automotive industry was a pretty closed industry, right? You needed to fulfill a number of quality requirements and process requirements. And if you were in the automotive industry, yes, that was a good thing to be. But for external companies, typically the entry hurdle were pretty high. So they focused on I would say electronic parts, which might not be so critical, consumer electronic, typical one, laptops, phones, smartphones, and other devices. And a lot of companies became very powerful in doing that because they had very high volume, they had fast turnovers, they had to make adjustments on the manufacturing process really quickly. So they kind of grew by doing that and learned. And in particular, companies like Flex and Jabil, they became like a tier two. Maybe in the past they were only able to assemble a PCB board, then they shipped that to tier one, we put that into a housing and did all the sealing and the mechanical requirements, which typically are higher in the automotive space compared to consumer electronics. But then they became tier 1.5, as we called them, right? So they had smaller products completely developed and shipped to the customer, and eventually became tier ones and are now fully integrated into the automotive industry. And even do development. It's no longer just what we call build to print, where someone else developed, let's say, the electronic or the mechanical parts, and then Flex and Jabil assembled them. They even build up electronic capability, design capability. Now, they are typically newer. They have embraced in AI tools or new processes in new machines, which give you all that capability much sooner than automotive companies. And because of that, they have now a certain advantage. And I think the automotive industry really needs to learn from them. How can you collect data? How can you analyze the data? How can you draw the right conclusions out of that? How can you implement better manufacturing processes, based on certain learnings from one side and deployed on the other ones? So this is, I think, where they have currently a clear advantage, but the automotive industry is catching up fast, and ultimately you see that convergence of these two different industries really coming together.
Yeah, we spend a lot of time in our advisory services talking about the software-defined vehicle, but when you look at manufacturing plants, they're rapidly becoming software-defined, manufacturing facilities. Every machine on the floor now talks to the internet, so that's one aspect. The other aspect is that when you take companies like Jabil and Flex and others like that are in that area, and by the way, there's a lot of automotive suppliers that are trying to get into that field. They're looking at, the business is going away from traditional parts manufacturing, powertrain manufacturing. Now I need to get into some other aspect of the automobile. Maybe it ought to be electronics. And they're making acquisitions. Companies like Lear has an electronics division, Magna, and many, many others. So as we start looking at how that starts to impact, what you find with companies like Jabil and Flex is that they look at data as a core manufacturing asset. Just like in a vehicle where you've got, data coming out of the vehicle is a manufacturing asset and is very valuable to companies like insurance companies, or advertisers or dealers that are interested in monitoring maintenance and things like that. Being able to get data out of your product or your process is absolutely critical. And these companies look at it as though it's a critical part of their overall infrastructure. So, if you think about the way that they operate, you can walk into a Jabil or a Flex plant, and everything is on one system, one platform. So you can go into any one of those facilities and you're going to see the same kind of screens, the same kind of dashboards, the same kind of data that is being pulled off of all that equipment. And it's standardized. The machines are standardized, so that you don't have 50 different, people that are specifying what type of equipment is coming into the facility. It's all designed at a very high level within that organization. And it's essentially by edict. So, it's not like we don't have advanced manufacturing groups within a lot of major automotive companies, both at the tier one and OEM level. But we need to do a much better job. Most manufacturing organizations in automotive today work around islands of automation. They've got data in different places, and not a lot of it talks to each other. So that's the big difference that I see when you start looking at companies like Jabil and Flex and to a lesser degree other companies in that space. They look at data as a key asset for where they're going. They're building upon the information coming off the floor. It provides a basis for learning, so that you can start looking at how do I improve my problem solving by having better data, and even using AI now, we're making decisions about what do we do with the process. Do we shut it down? Do we need to change tooling? Do we need to be doing something else to the process? Are we entering a maintenance cycle? So now we can start planning for it instead of just having it occur. And what you see is, instead of a hockey game, you see more of an orchestrated, type of situation. It's more of a symphony than the typical manufacturing hockey game that we live with every day. Where you drop the puck and everything that happens in a scramble. Um, and that's where we have to get to if we're going to be effective in global competition, because that's where our competitors are.
Maybe building on that too, not a hockey game, but a symphony, and like the directors are the C-suite instead of it's happening in the corner. Because that's the other thing, right? That at Flex and Jabil and Sanmina and Foxconn, Wistron, these growing electronic EMS and ODMs, factory performance is strategic at the C-suite, right? It doesn't just end at a particular director or VP, and then the C-suite is really focused on new product introductions or sales and marketing campaigns. Like, factory performance goes all the way up to the top. So you talked about those standard dashboards. Jabil famously has the Blue Sky, and Flex has Pulse, and et cetera. And the C-suite themselves will know they go there with their customers, they show it off. It seems like that's not so much the culture, but tell me if I'm wrong, but it seems like that's not as much the culture at the C-suite of the automotive tiers. And what do you think, Bruce, is necessary to elevate factory performance as a strategic priority in the C-suite?
Well, in terms of the incentives, I think that it it really gets down to, you're running a large manufacturing operation is a lot like being a mayor of a city. You've got all these different things that are going on. You've got a hospital, you've got fire stations, police stations, you got infrastructure, water, electricity, all the other kind of things that are going on within a large city. And you've got people that are involved in the process and things like that going on, but you've got imperfect data coming to you as the mayor of that city. It's a lot like that coming to the plant manager. How am I going to run this operation if I don't have accurate and standardized data that I can believe is really telling me what's going on in the corners of my facility? And where do I put my resources to solve those problems? So I think that those are the kind of things where we have to take a look at, how do we start applying that kind of information and getting it on a standard platform where everything talks to everything else, and then applying the AI solutions that can help us determine what action is appropriate for the data that has just come in. It's got to be not a hunch, not I've seen this before and I think this is where we ought to be putting our efforts. It needs to be a data-driven decision based on the information that's coming off of the process, and it's going to take time to get to that point. But I think otherwise we're just doing what we've always done, and that's not how we're going to move manufacturing forward. So in terms of incentivizing the process, the one thing I can tell you, in having done some of this in my career, when a plant runs the way it's supposed to run, your job is so much easier as an operating executive. It just runs. Whereas every other day, you're killing yourself trying to solve the problems or get the resources in place or get people to listen to you to help you solve your problems. And, instead, it's now like I've got this very valuable tool that tells me exactly what I should be doing, and then work from there.
I get so frustrated too by this idea, with the shift to electric cars and some of the dominance of the Asian manufacturers. It's like, well, they've been building iPhones forever, and an EV is an iPhone on wheels. So it's like, it's over, they've won it. And now we can only run backwards to a gas car. And that's just like a terrible mindset. Like, I don't believe that at all. Like, I believe, one, you can build electric cars fantastically in US and Europe. And two, you can also innovate the gas cars and like, gas and combustion has a huge role in the future, both with gas, with hydrogen, with other technologies, and transforming that manufacturing. So I think that's key too, is like, none of this like defeatist mindset that the iPhone on wheels is, it's gone to Asia, it's over, and gas is just going backwards. Like we have to go forward into manufacturing innovation and automotive.
Well, and we've got so much variety in the way that we do businesses from manufacturer to manufacturer that you're absolutely right. We're not going to throw that investment away. We've got to figure out how do we make it work for us.
Yeah, that's fantastic. It's interesting. I want to come back to something you talked a minute ago about by having that data foundation. And you mentioned earlier, Bruce, that with the see Tesla as a software company. I've heard many times Tesla's not a manufacturing company; it's a data company. So it's kind of a little bit of all of that. Mark, I have a question for you then. As we talk about the data, we know that it's probably next to people, it's the most important resource, the most valuable asset in manufacturing right now, for all of the reasons that we've talked about. And I feel like we talk a lot about how behind the industry is, and we feel the pains of where it's behind, but there's also some really remarkable things that are happening on the transformation front in the automotive industry. Looking ahead, we used to say manufacturing in 2030, and it felt so far away. And now it feels, especially in the age of AI, like we're hurled there quickly now. If you were to look ahead, Mark, and predict the next 4 or 5 years, what are some of the characteristics that are going to define some of these winners in automotive manufacturing? What are the mindset and capabilities that you are seeing emerging right now that you think are going to actually separate those that will start to lead and separate from those that are starting to fall behind?
Yeah, I think it's comes really down to successfully implementing the digital transformation, right? We are at the starting point. I think the automotive industry understood clearly how important that is. It's following other industries here. It will take some time, but by 2030, I really envision that the suppliers who will be left, to be honest, right, because the other ones have a really hard time, which are not doing that in a successful way, they will base their success really on two complete different ways how they operate. And the first one is the data, right? It has been mentioned a couple of times already. I think we are at the point where we build up how we collect data. More and more of the equipment is able to collect it with the sensor equipped and so on, and the communication capability. We are starting to gather the data. I think the big missing piece here is really how we can successfully analyze the data and segregate it, and ultimately what kind of conclusions are we drawing out of the data. Everyone is talking about that big data lake, and it almost feels like a lot of companies are drowning in that data lake because they don't have a good way how to analyze it. So companies in 5 years will have figured that out to a large degree, and AI obviously is helping. AI is really good in handling large amount of data and consolidating it to a point that we then as human beings can step in, and again together with AI can draw the conclusions really what needs to be further improved, and how can we derive certain standards from that one. Then the second one is virtualization, and that has started, I would say, to a large degree already on the design side, with software, for example, where you can develop software which later runs on a control unit, even if that control unit is not around yet. The hardware has not been built yet, the hardware has not been designed potentially even, but you can simulate your software functionality on your desktop computer, on your laptop, right? That's how it starts. And now moving down that path to a full digital twin, more and more of the physical properties of the products, starting with the hardware, the software, as I mentioned, the hardware as a physical property, then mechanical, then you put everything together. You will see tremendous increase of simulation capability compared to today, where we still rely to a large degree on physical samples, to validate them. But as we virtualize all of those components, we can skip the step of early samples. We can just virtually simulate the performance of these samples. And then later on, we do the same, obviously, on the manufacturing side, right? So the complete production line is getting simulated first, and not only with maybe simple ways, what's the rate and the capacity and cycle times and other things, but even to a point, where do you expect issues, the stack up, tolerance stack up issues, for example, or where you have certain processes where you need to sort parts and that can cause issues. So I think you will see that these companies have done significant improvements. I've seen significant improvements really in that virtual part. And altogether then allows them to be more agile, right? If you can do the validation of your product and the validation of your manufacturing in a virtual environment first, then you become more agile. And you can really embrace that methodology of DevOps, as I mentioned it earlier. And all of that ultimately leads to the idea of software before hardware. Start with the use cases, implement the features on the software side, develop everything you need on the hardware side and the mechanical side later on, shorten the process because you can simulate many things. And then you have faster development cycles, you have more exciting products, and you can keep them exciting, right? Because after even you ship that car to the consumer and they drive it for typically an average time of 10, 11, 12 years, you can provide updates, to features which they might not even have thought of as they purchased the cars, but now will then later on enjoy them. And the industry is heavily exploring how they can be even monetized, that later on certain updates are only sold for either subscription fee or a one-time fee or something like that. So all these aspects together will significantly change how we define vehicles, how we design vehicles, how we build these vehicles, and how consumers are using vehicles over the lifetime.
That was an impressive and fantastic set of predictions from the factory to the final delivery of the vehicles. Bruce, maybe one more. This has been such a great conversation, but if you were starting a new automotive manufacturing supplier today, what would you prioritize from the beginning? What mistakes would you avoid?
Well, I think it's important to recognize that you've got a whole generation of leadership that doesn't really understand what AI is. They know from what they see on the internet or other things that there is no consistent teaching of what AI as a tool can do for board level people, for operating management. So we almost need to make sure that we're putting forward a concerted effort that shows it's not deep fakes and things like that. It's a tool that can do, as Marc was saying, simulations that can get us so close to an optimized process that very little tweaking is going to be required. So I think, first of all, training is going to be a big part. Unless you are coming right out of university and had experience using AI, chances are, if you're in industry, you're going to need some background. Otherwise, you won't know how to use the tool. You won't know what the benefits of the tool are, and you sure won't be able to optimize it. But as we spoke about earlier, if you were creating a brand new process, a brand new facility, I think getting a common architecture, a platform where everything talks to everything else, your scheduling, your sales, group should be talking to the plant itself. Ordering of raw materials, the scheduling of your shop, where you've got big complex processes, you've got hundreds of SKUs, like an electric motor manufacturer, for example. You've got hundreds and hundreds of different products that you're producing for a variety of customers. So you've got all these different combinations, and AI can be such a tool to optimize how you schedule that plant. And you can optimize around equipment utilization, you can optimize around margins, you can optimize around so many different things. Even your work patterns can be optimized to, through AI to make sure that you're working the right number of hours on the right product to give you the maximum margin that you're seeking. So those kind of things are critical, and unfortunately, it's not a big enough issue at the board level in many of our companies because they don't have exposure or experience using it. They just see it as what they see, on the internet, and it's not going to be enough. So I think, getting the right architectures, getting the right people, doing the right training, making sure you've got systems and processes that are built to provide the data that can provide the information for you to make decisions through an AI process is really the way to go. And you're gonna deliver better, higher quality products. You're gonna have better schedule conformance. You're gonna have better, overall customer satisfaction. So it's something that we as a society need to learn to use better. Manufacturing is just one area where this is going to help. It's going to help in so many other areas as well. But we're going to need, all of us, to learn how to use this to make it the kind of tool it can be. Otherwise, it'll be a tool that just provides a lot of disinformation and deep fakes, and it doesn't provide a whole lot of societal benefit. So I think it's a huge challenge. Like anything that is on the cusp of changing the way that we work and live, we have to figure out how to use this as a tool.
Yeah. We will make it what we will make it, right? It's up to us.
That's exactly right.
This has been such a fantastic conversation. I can't thank you both enough for coming on the podcast today.
Yeah, absolutely fascinating. And
Pleasure.
your experience is just inspiring. It's good discussion. Thank you very much.
Great discussion.
For the work you do.
Enjoyed it very much. Thank you.